So now we are going to wrap this area up. So what I like to do for the wires coming through the holes, I put a small piece of a large shrink tube and then just place it. It doesn't have to be too big, just enough to shield it from the, so such. What I did here was create a little shield that prevents any of the case to rub on this. And I did smooth out these holes, but I do like to have the extra precaution so that over time these won't short out. Okay, we got all that done, and now we're going to start the cutting and securing the primaries to the terminal strips, and then also connecting the power switch position and the neutral to each of these to distribute the power. Once the power switch is flicked, each of these will be fed. You could do stuff like this, I mean, but that just looks retarded. So it would be easier just to have these here and then distribute the power to these. It's up to you, however elegant. For example, this one will reach, you could zip tie this, bend it, but in the end, it's all about aesthetics and craftsmanship. So depending on how you feel about that, you can just do some wanky shit. So we'll separate these into little areas, and just to help you out during this process. You get my drift. These are the spots where I put the Hammond stickers, so when it's serviced in the future, somebody will know what these transformers are and can reference the data sheets and test it if it has any faults. These are the control amp output transformer. We will connect these all to the board. The orange all connect together, and then we'll connect to the 420 volt line, 420, 460. If you hear either, it is the same because it will fluctuate depending on your mains, since it's not regulated. So something that you could do would be to go ahead and wire these to a terminal block, and that would allow one nice wire to go to the main power supply board and connect to the 420 volts. These are the center taps of the output transformer. These will be carrying a lot of voltage, and so when you do connect these, really take some good caution. Prepping the wire for the barrier strip, leave a little curl in it, about a little bit of slack. You don't want these going like that. That doesn't allow any strain relief whatsoever, so leave a nice loop, and that allows for readjustment in the future. So you want to leave about that much, and then you can just loop it up, and 2 inches of slack and then curl up. So we can just go as such. Same thing here. And depending if you want to join these together, so you would make them the same length and mount them in the middle. So let's do that. It'll look much better. It would be easy just to do that, and that is an option. So, but I'm just gonna, since I have these here, I'm just gonna do it like this and shut up. So now let's strip these guys. You only want to take off enough wire to fit the depth of the collar of the spade. Leave the choke wire. Leave the choke wire out of this right now. Just use some tape. I like to keep things out of the way while I'm working, so not to accidentally go apeshit and cut something I don't need to. And yes, I know I'm using scissors, but they work. So since this wire is so thin, you can actually just fold it over and that'll help keep it in place. Like my clean these guys up to make sure there's no stuff on them. You can use a crimper just the same. I don't have one. The one I do have is really sucks, and it's a lame one from Amazon. I think there are a couple good ones that you can get. I just had, my luck ran out that day. If you're going to put two connections on top of one another, you should have the first one upside down, in order to keep the connections from turning in the future. I put a zip tie right on top of the crimp part. So there's that one. Love these. Ow. Keep these both perfectly straight when so zip tie these. See, now you can see why I sell a 670 for 8,000 bucks, because this is total monotonous stuff to do more than once, which I hate more than anything. But sometimes I need to finance one of my crazy ideas, so I will make a deal with the devil to do this. This will be my 15th. And hopefully my last. So on all of the secondaries, remember, primary means connects to the power switch. Secondary means the voltage that is desired. Since it has a diode bridge in the heater, you do not ground the center tap, so you can isolate this green yellow on the PCB, but it is a thick wire, so since we're here, we might as well go ahead and mount that securely to this barrier strip. So cut that to, go ahead and do that for all of the center taps. Make sure it has the yellow band, otherwise you just screwed yourself by cutting it too short. Since these wires are so thin, I just cut it longer and then fold it over. It doesn't interfere with the connection since nothing else is going with this. And that holds it in place while I'm soldering it. Now insert these wires into the barrier strip and isolate. It's close to that bolt, but there is plenty of clearance. It's not going to short anything since it can't actually touch it. I hate that bolt. Let's just move it over here. Okay, now that we have that nice and secure, you can see we have isolated center tap, primary high, primary low, isolated center tap. On the 12 volt and the bias transformer, we have the 12 volt secondary center tap isolated. We have the primary high, primary low, the bias center tap isolated. Nothing will connect to that. When this is all wrapped up, you will go through each of these screws, give the wires a tug, make sure they are soldered, and make sure everyone is secure. Make sure the orientation is straight and that there is no clearance issues of possible things that this collar of the spade connector can short out on. This section will be covered, so accessing it later on will be a bit of a chore. You'll have to disassemble, pull the back panel off, and then tilt it back. And that's also a reason why you don't want to cut things to exact length. When these go to the board, you should leave most of the wire, cut them to the, make sure that these are even. But what you want to do is, if the back panel needs to be dropped, there'll be enough slack in the wire where you won't have to disconnect all of the secondaries just to access the back panel and service it or troubleshoot a problem. So same thing goes with the output transformer wires. Don't cut them to the exact length. Leave as much of the length as you can, once again, so you can drop the entire power supply, possibly just leaving these 2 bolts still on the case, and bring it forward, do what you need. But same thing applies here. We are going to isolate the center tap on the main 750 volt transformer, and we will also isolate the 5 volt center tap, and also we will isolate either the gray or the black once we determine the voltage that I want this at, either 115 volts or 125 volts from your mains. So that concludes this video, and we will continue on wiring up the main 750 volt transformer in the next one. So thank you very much.